Good morning, sweet baby angels. I wanted to make you guys one more quick video to kind of clarify some of the topics that I gave you in my YouTube video on Tuesday about gas laws. So remember, I introduced you to 3 gas laws. They were Boyle's Law, Charles' Law, and Avogadro's Law. I asked you to answer 4 questions for me for your assignment. The first was, what are the variables in each gas law? The second was, what are the constants for each gas law? The third was to define the relationship between the variables of each gas law. And the fourth was to give me a real-world application of each gas law. So, let's go back to the beginning. What are the variables of each gas law? Well, to know this, you have to understand what a variable is. And a variable is something that can change, okay? The variables are always represented in the equation. Okay, so if we go to Boyle's Law, the variables here are P and V, pressure and volume. Okay, each variable changes when it goes from 1 to 2. Now, I'm sure y'all notice the subscripts here. We got P1 and P2, V1 and V2. This change from 1 to 2 is what's happening with your gas, okay? The pressure is changing, the volume is changing, and that change is what happens between 1 and 2, the difference between those 2 values. The 4 variables that we deal with in gas laws are pressure, volume, temperature, and number of moles. And these are the letters that represent each. The next question was, what are the constants? So a constant obviously is something that doesn't change. For the relationship of 2 variables to be true, okay? So let's take Boyle's Law. For the relationship between pressure and volume to be true, some things must not change. Now, the way you know this is if a variable is not represented in the equation, it is a constant. So remember, we only have these 4 variables to work with: pressure, volume, temperature, and number of moles. So for Boyle's Law, pressure and volume are your variables because they are represented in the equation, and temperature and number of moles are your constants because they are not represented in this equation. We assume that they stay exactly the same. The temperature doesn't go up or down, and you don't add any more gas to it. If that is true, then this relationship between pressure and volume can be true. I hate that dog next door. What is the relationship? Now, relationships are one or 2 things, and I think this is where I saw the biggest problem with the answers I got back from you so far. You guys didn't really tell me direct or indirect, which was all I was looking for. In a direct relationship, guys, the variables, they change the same way. If one goes up or increases in value, so does the other one. If the other one goes down or decreases in value, so does the other one. So if you look here, x1 goes to x2, it goes from 5 to 10, which means that x increased, right? 5 goes to 10, that's an increase. Y goes from 10 for y1 and 20 for y2. So again, it's increasing, yes? 10 increases to go to 20. Both variables increase, which means it's a direct relationship. Let's look at inverse relationships. Inverse is when one increases but the other one decreases. So if you look, x1 is 5 and x2 is 1. So we can agree that x decreased, right? It went from 5 to 1. But if you look at y goes from 10 for y1 to 50 for y2. So y increases. So x decreased, y increased. And this is an inverse relationship. So for part C, when I ask you to tell me the relationship, you should either say direct or inverse. Now, how do you know? The only way you can know right now from what I've taught you is to look at the equation. How do you know the relationship? Well, if the variables are multiplied, as in x1 times y1 equals x2 times y2, that is an inverse relationship, okay? So if you look up here, the only one that's inverse is Boyle's Law because they are multiplied by one another. To kind of show you this, you can see x1 goes from 5 to 1, as it does here. So it decreases, that's my little arrow for you, going down. Y increases from 10 to 50, okay, so the arrow goes up. And you can see that as one goes down, the other goes up. That is an inverse relationship. Variables that are divided, okay? So they're going to be stacked like a fraction. You've got x1 over y1 equals x2 over y2. That is a direct relationship. As one increases, so does the other, or as one decreases, so does the other. Again, if we put in values, x equals 5, x2 equals 10, that's an increase. Y equals 10, y1, and y2 equals 20, also an increase, direct relationship. And if you do the math on that, 5 divided by 10 is 1/2, 10 divided by 20 is 1/2, and they are in fact equal to one another. So I hope that helps. For real world examples, I'm going to do a few experiments for you, and you guys can check them out.